So I'm going to focus on telescoping and geometric series. Also going to be talking a little bit about, I guess I should put it down here as method 6, because it is a method. And we're going to look at a family of series called the harmonic series. So let's look at method 5. We have touched on these, so these aren't new. So when you're trying to decide if a particular geometric series converges or not, we're going to use a test called the geometric series test. And what it essentially says is that if the common ratio R, if the absolute value is less than 1, it converges. And if the absolute value of the common ratio is greater than or equal to 1, then it diverges. And not all the time, but there's a lot of questions that when it converges, you're being asked to add, find out what it converges to. And in those questions, it converges to a very simple fraction, A over 1 minus R, where A is the first term and R is called the common ratio. And if you want to kind of in general, how would I calculate the common ratio? How about the second term divided by the first term? Wouldn't that do the job? And since A is the first term, isn't A just whatever A1 is? No. So there are I guess there's 2.5, it's not quite 3. 2 different major ways and one kind of semi-common way of giving you a geometric series. So the first one gives you where it's written down with sigma notation. And I'm deliberately picking an ugly one. Normally they're a lot nicer looking than that, but I'm picking this one. And the reason why I want to pick this one is I want to show you that, well, first, they always tell you it's a geometric series, so you don't need to say, is it one, right? You're told it's one. But when you've got something written down in sigma notation, especially if it's a very ugly looking sigma notation, it might not be that clear who A and R are equal to. So let me show you how you would do that.
Is that 4 to the power of n minus 1, or is that 4 to the power of n minus 1?
It's 4 to the power of n minus 1. Does that help? I don't know, that probably makes it
Yes,
worse.
thank you.
Right. So to find A, that's the first term, you get A1. So you plug 1 in here. So it's going to be 5 times 3 to the power of 1 divided by 4, and 1 take away 1 is 0. So would you agree this is 5 times 3 divided by 1? And I'm taking it really slowly. Would you agree it's 15? Are you happy about how I got A1? Now, isn't A1 actually A? Right. Now, what I'm now going to do is find A2. And it's not that much different. If you want to find out what A2 is, don't you just replace the n by 2 and the n here by 2? So it's going to be 5 times 3 squared all over 4 to the power of 1, which is 9 5s is 45 over 4. Are you happy about that, guy? Now, to be able to decide, does this guy converge or not, don't I need to find the common ratio? Now, in a lot of cases, the common ratio could almost do it in your head, but you can tell this one's not that obvious, right? So the common ratio is going to be the A2 divided by the A1. So this is kind of going to be the process you're going to do when the series is really ugly looking or just not clear what the R is. A lot of times you can look at it and say, yeah, it's a half, it's 7/9, right? But in this case, a little bit trickier. So what's that going to be? It's going to be 15 divided by 45 over 4. That's going to be 15 times 4 over 45. Are we good? Okay, what's that going to simplify down to?
4/3.
So we're going to go for a 4/3.
I
Okay. Question.
I think
That's
is this
screw up.
division backwards? Because you
Oh.
did 15 divided by 45 over 4, but I think it should be the other way around.
Oh, shooting space. Thank you. It should be A1 divided by A2. Yeah, it's early in the morning. My apologies. Oh, can I tell you then that A1 divided by A2 will actually be the 3/4 then?
I think A2 over A1 was right. You just put in the formula, you put in A1 over A2 to get 4/3.
Oh,
Yeah, it's still 4/3.
well, is it? Let's just take it again. The common ratio is A2 right, over A1. So it's 45/4 divided by 15, right? That's what I should have done. The answer is going to be 3/4. That's going to be the same thing as 45/4 times 1/15. Are you happy about that? Now, if we cancel them down, that's the guy I should have got, and that's the 3/4 we talked about. So I just wrote the two guys back to front, which is annoying. But you would have been told pretty quickly on WebAssign that you'd screwed up. Now, is that guy going to converge then? The common ratio is 3/4, yes. So the absolute value is less than 1, so it converges. And maybe that's all you want to know. But let's suppose they ask you what it converges to. So A is 15 over 1 take away R, which is 3/4. That's 15, try to be careful this time, over 1/4. And I believe that ends up being 60. Are we good with that? Apart from the little hiccup of me getting my A1s and A2s mixed up at the start. If you're looking at that guy, as a double check, 15 divided by, put a bracket around it to be sure, 1/4. Yeah, I convince you it's 60. And we are good. So if you get a really ugly sigma, find A1, find A2, make sure you remember to divide them the right way around. A2 take away 1. Just make sure that you do that one divided by that. You've got your R value. And then you can move on to the end. Now I promised you kind of 2.5 method. So let's show you method 2, where you might get a sequence or a series, which is a sequence added up of this guy. In fact, this one is just because it's in front of me, number 14, or a version of it. So how do you test it when the geometric series is written down in this format, right? No sigma notation. Well, in a lot of ways, it's easier because doesn't that one give you A, which is also A1? And doesn't that guy give you A2? So the common ratio is A2 over A1, which is 4 over 5. And doesn't that converge then? You happy with that? And what does it converge to? Whatever A over 1 minus R is. Whatever 5 over 1 take away 4/5, which is 5 over 1/5, which I believe is 25. And I said there was like 2.5 methods. So here is the half method. I think it's only one question, so I'm not picking the one that they picked, because that would be it. You wouldn't get any more shots. Yeah. It's like question 31. And in question 31, they say, express this repeating decimal as a ratio of integers. Well, if I was doing that question, I would say, express this repeating decimal as a fraction. So you might think, what has that got to do with a geometric series? I can understand that. Doesn't look like it's got a lot. So it's 0.12 add 0.0012 add 0.000012. Would you agree that this series would add up to that decimal? Do you recognize that this series is a geometric series? Let's check it out.
Yeah.
This guy is A1. This guy is A2, right? So that's also going to be called A. Won't the common ratio be that fella, A2, divided by this fella, which is 0.01. So I'm going to leave it as a decimal. And the reason why I'm leaving this as a decimal and not doing it as fractions, isn't it the kind of rule, if the information is a decimal, just work with decimals. If the information is fractions or whole numbers, work with fractions or whole numbers. So I'm just being consistent in the way the information was given to me. So it's given to me as decimals. So does that guy converge? Well, would you agree that that is less than 1, so it does converge? Which isn't really a surprise, because we kind of know what it converges to. Shouldn't it converge to that guy? So it's A over 1 take away R. It's A, which is 0.12 take away 1 minus R, which is that guy. So far, so good. Now things get a little bit messy at the end. Are you cool with that? Now the problem. If I just try to find out what that is, do you know my calculator's just going to give me a decimal? In fact, I can tell you what the decimal is, isn't it going to give me that decimal? But remember, the goal here is to get a fraction. So how about this little algebra trick?
I mean, you have a fraction right now, to be honest.
Yeah, but I want a fraction with whole numbers. That's the only difference.
Divide both of those by 3.
Oh, yeah. How did I get from here to here? Because I am
Multiplying by 100.
Are you comfortable that the answer that we're looking for is what fraction would be the same value as this repeating decimal? And the answer ends up being the fraction 4/33. Right, fractions should have whole numbers top and bottom, right? So to get from here to here, I just multiplied everybody by 100 and then a little cancel down after that. Now, if that is correct, fingers crossed, when I plug this guy in, shouldn't I get 0.121212 forever? So 4 divided by 33. Are we good or are we good?
So if this was on like a quiz or a test, would we have to show all that work
Yes.
if we already knew that like 12/99ths, like anything, like 2/9 is 0.2 repeating and
Yeah.
same with the 99ths?
Yes. You'd have to show me. I'm not interested in the fraction. I'm actually more interested in the process where you can prove to me it's a fraction. So this is the process that we're interested in. I mean, I could say 0.11111, right? And you could say, oh yeah, I know what that one is. Or let's pick one everybody knows. 0.33333 is a third. Great. But if I said to you, prove to me it's a third. Proofing doesn't mean I went to my calculator and did 1 divided by 3 and I got the same answer. Although you might think that's proof. That's how engineers prove things. Because theoretically, couldn't that answer be 2 million threes and then a 5? There's no guarantee that just because the calculator to 8 decimal places agrees with what it should be, it doesn't mean that it is correct. Would you agree this process doesn't care that it's infinite? Doesn't this process actually work with infinity in a way that's allowed? And so this is a proof rather than an answer. And sometimes people find it kind of frustrating. They think, well, I got the answer. Well, yeah, you did, but prove it to me. It's more important. Are we cool with the geometric series, guys? Okay, so what I'm going to do is I'm going to go back and we're going to look at some more questions that involve geometric series, maybe talk through them. If we need to, we'll do one. And if that's definitely, you know, stick a fork in it is done, then we'll move on to telescoping series. Okay. So
Can I ask a question?
Sure.
Would that have worked if, like, so you had a fraction that was repeating. So like I think on mine it asks me for 0.44444444 on into
right.
Would that work if you just had a fraction like say your fraction was 0.125? I mean, I know that's an 8, but could I take that same math and say that my first number is 0.12 and then my second
it
number
wouldn't
is 0.05?
work. Yeah,
Okay.
it would not work on a repeating decimal. And the reason why it wouldn't work on a repeating decimal, if you tried this method, you wouldn't be finding 0.125. You'd be finding 0.125, 125, 125, 125, which is not the same thing. Right?
So it has to be a repeating decimal for this.
It has to be a repeating decimal for this method to make sense, or to give you an answer that makes sense.
That's a bummer.
Oh, yeah, I don't know. I think nice fractions work. Right, let's start. Oh, I should check because some people's things don't work. That's okay, Mike. Right, here we go. I have no idea where I should start here, so you're going to have to bear with me just for a few seconds so I don't make you too dizzy. Okay, I think 13 is the first one. Would you agree that guy is the number A1, A2 technique that we talked about? Would you agree that's just another one of the same idea? In fact, if you look at this, would you agree the answer is 4/5 and it converges? And the answer is -8/3 and it diverges. Can't you look at them very quickly if they're nice numbers at the start at least? So see what this is, right? A2, -8, divided by 3. Isn't -8/3 the absolute value bigger than 1? Can't I look at that one and just stick in the word diverges? Would you agree that's just an A2 divided by A1 technique again? Right, so that's another one of the same. What about this guy? A2 divided by A1 again?
That's going to be less than 1.
Yeah, it will be. Won't you just be working with decimals rather than fractions in this one? But apart from that, it's the same question.
Or you could write 1/4 as 2/5, or I'm sorry, 0.4 is 2/5.
Yeah, would work if you want to do that. Isn't that going to be the plug n equals 1 to get the first guy and plug n equals 2 to get the second guy because it's just really ugly and you don't want to get too caught up? And remember to do A2 divided by A1 in the correct order, unlike I did the first time. Now, because they are telling me it's a geometric series, this one is going to be done the same way. Would you like to see a version of 18? Okay, so let's write that.
Just to clarify, it's A1 over A2, right?
No, A2 over A1. A2 on the top, A1 on the bottom. That's to clarify. So this is version 18, or at least like 18. Anything in WebAssign that's red gets randomized. So your question might be 7 over pi to the n or whatever. So let's go back to this fella and set this fella up as a kind of proof. Well, I'm assuming it's going to be a proof. We'll see what we get. A1 is what you get when you plug in 1. So in this case, 9 to the pi. A1, by the way, is the same thing as A, right? A2 is what you get when you plug n equals 2 in. So that's going to be 1 over pi squared. The common ratio is going to be A2 divided by A1, which is going to be A2 divided by A1. That's the same as this guy multiplied by his reciprocal. So do you see here, calculators are not going to help you. If you try calculators, you just get weird decimals, right? We have to just do it by hand. Now, the 9s will cancel and they'll partially cancel. Are we happy about the common ratio being 1 over pi?
So it
We all
converges because it's less than 1.
And it converges because it's less than 1. So you do a little line that looks something like that, right? So everybody knows why you're saying converges. And then, since this question is find out what it adds up to, at least when they converge, you do this step. It's going to be A, which is 9 over pi, 1 take away R, which is 1 over pi. Now let's look at style points. Nobody is going to be happy if that is the final answer. Would you agree that is clunky and not pretty? I want it to be a nicer fraction. That means fractions that don't have fractions in them as well. What special version of 1 can you multiply this guy by to just make him pretty?
Over pi.
And when you do that special version of 1, the top line becomes 9, and that becomes pi, take away 1. Would you agree that's a much nicer looking answer than it was a minute ago? And that's how you would tackle that question.
I have a question about finding R on a test.
Mhm.
Would you give us full points if we just took the sigma and then factored out that 9 and then wrote basically sigma of 9 times 1 over pi to the n? Could we just then say that R is 1 over pi?
Yes.
Okay.
That would be accepted. Some of them, you can do that pretty easily. Sometimes they just get really ugly. So the method I've shown you is kind of longer, but safer. But the method you mentioned is totally valid and it does work. You'll have to do a little bit to figure out who he is. So be careful when you do that technique, because sometimes you get confused. I'm going to return back to the homework now. Still on geometric series. Would you agree 19 is probably best done as an A1, A2 the long way again? Just too much going on there. Would you agree that this one is divide? Well, let's, whoa, hold back. No, forget 20. That's harmonic. Forget that one. Right, I'm looking for geometric.
I think that's geometric because the bottom two
It's
is multiplied
geometric.
by 9 every time.
Yeah, and the top's multiplied by 2 each time. I'm just wondering
So
why they
could
did.
I just say on a test like that that R is 1 over 9 because each one of these gets bigger by 1 over 9?
Well, it's not. It's 2/9 in question 22. But if you meant to say 2/9, then yes. But you still should prove it to me. You should do an A2 take away A1. I was wondering why this one didn't say a geometric series, but I guess sometimes they just don't tell you. How did you recognize that one as a geometric? Which is?
Because they're increasing by a constant amount each time.
And when you say increasing, you mean you're being multiplied by the constant amount each time?
Yeah, the top and bottom are both going up by a common factor or a common ratio, I think is the word.
So that would count. Now, if you wanted to do this one, wouldn't you take, if you couldn't see it was 2/9, couldn't you take this guy here, this A2, and divide it by this guy here? And can you trust me that it ends up being 2/9? And then since that converges, you would do a 2/9 divided by a 1 minus 2/9, because A happens to be 2/9 and so does R in that question, and you get your answer. That one's telescoping, don't want that one. Ooh. Do you recognize that guy as a geometric, even although they didn't tell you?
You could rewrite that as 8 to the n plus 1 over 9 to the n.
Right, does it look more like a geometric when you write it that way? And it is geometric, so won't you just find A1, A2, and off you go?
I'm not sure. That's one of the few ones I had issues with.
Because it looked so ugly, or you weren't sure about it?
I just couldn't figure out how to separate them.
Would
Guess
you
it's
say-
1 to the 9 minus n is the one that confused me the most, I guess.
Couldn't you separate them as 1 or the 9 as 1 over 9 to the n?
Well, let's show you. There are different ways of looking at that. I'm not saying any one way is better than the other, but it's a good question to play about with for a few minutes. So what we're going to look at is just, this is how my brain sees it. I'm not saying it's the only way or even the best way, because I know it's not. Right. That's the guy. And geometric series kind of have fractions in them most of the time, at least, or at least a single term. And I'm saying, does that look more like a geometric? Right. Now, there's lots of different pathways. Here's one. Does it look even more like a geometric? Now, I'm not saying that's the best way or the only way. If you really get stuck on that one, couldn't you just plug n equals 1 in, n equals 2 in, n equals 3, n equals 4, make the fractions look pretty, right? So don't leave it as 9 to the negative 1 or 9 to the negative 2, right? Call it 9 and 9 squared and 9 cubed. And maybe then you would see a geometric, right? Life is so much easier when they tell you it's geometric. Then all you need to do is figure out A1 and A2 and R and you're good to go, right? But when they don't tell you it's a geometric, yeah, you do have to think about it. Right. Now, if I picked you up correctly, were one of you thinking it looked like that? Nothing wrong with that. If you plug n equals 1 and n equals 2, won't you get the values you need in your geometrical work? So, to quote a phrase that I use a lot, there is more than one way to skin a cat. You've all heard that saying, right? Do you all, this is side issue, but it's in my head, so I have to get it out. Do you all think that's actually got something to do with somebody who catches cats and skins them? You know, and you can skin them by slitting their belly open and doing it that way, or cut their head off and do it that way. It has nothing to do with cats. So if you thought that saying there's more than one way to skin a cat was to do with some perverted person who skinned cats and figured out 4 different ways to do it, nothing to do with that. Does anybody know where that phrase actually comes from? Then you are going to learn something non-mathematical today. It came from the olden days in the Navy and to do with punishments. They had a whip called a cat of 9 tails. It was basically just about a whip with long strands of leather coming from it, right? So it wasn't a single whip, it was very often 3 or 4, or if it has a 9-tail one, it would have 9 strips of leather, and sometimes even tied knots on them to make them worse. And you used to get a punishment like 20 lashes or 5 lashes, or 100 lashes would probably be a death sentence, right? But you got a certain number of lashes, right? And they would if you watch the old pirate movies, right, they tied you to the mainmast, and the guy would hit you with a cat and 9 tails. Well, evidently there was different versions of that punishment. Let's suppose you were going to get 10 lashes. And the nicest version of that punishment was you can wear anything you like. So what they would do is they would wear a leather jacket, a shirt, and not somebody else's leather jacket. They would wear everything they could get so that the 10 lashes wouldn't really affect them. And the worst version of that is pure skin. So there was more than one way to skin a cat, was just basically to do with that punishment. And now you've learnt something totally unconnected, and it's probably going to make you spend the next 3 minutes trying to focus on the next question. So let's get started on the next question, and it's over with. If you ever get me, you gotta just live with the fact that I distract myself a lot. Okay, are we back looking at question 24? Okay, 25 has nothing to do with that guy. Here is a sneaky one. 26 is a geometric series. I know they didn't tell you, but it is. What is the common ratio? What number is the common ratio in question 26?
Sine of 500.
Right. And I do not know what the sine of 500 is. I can find it out in a second from now, but I do know something. Isn't it definitely between 1 and -1 because the sine of everybody is? So won't that one converge? And won't A, B, whatever you get when you plug in 1? And then I believe their answer is going to be really ugly. It's going to be the sine of 500 on the top, 1 take away the sine of 500 on the bottom. And that's as good as it's going to get. So don't worry about making it look pretty. That's nothing to do with us. That's nothing to do with us. That's nothing to do with us. Right. That's us covered all the geometric. So move on. Any questions about geometric? Have we covered enough? You feel good about them? Okay. So the next one on our list is going to be, I don't know, number. Let's do method 6. Let's look at what are called the harmonic series. You have met this guy before because I remember talking about him. This is the mother of harmonic series. This is where they were all born from. And harmonic series diverge. And you kind of trusting me on this that they diverge. If you ask me week 9, I'll prove it to you, right? But right now we're just going to say, okay, I trust you. If you tell me that this series diverges, it does. And you can prove it, pseudo prove it, you know. The first 4 terms add up to more than a half. The next 8 terms after that add up to something more than a half. The next 16 terms add up to something that's more than a half. You can do that forever. So what you're basically doing is adding up an infinite number of pieces, all bigger than a half. And would you agree an infinite number of halves is still infinite? So that's a pseudo proof. Now, if that one diverges, what do the family of them look like? Well, there's a couple of versions of the family. There's one. Now, what would that look like? Well, I'm putting 1 in here. I guess if I start with 0, I get 1. Right? No, I won't. I'll get 1. I'll stick to my first answer. Right. I'm going to get a half plus a quarter plus a sixth plus an eighth. That diverges. Do you think sticking an 11 on the top of that's going to make any difference?
I think you could just throw any constants A and B on the top and bottom. It wouldn't matter.
Agreed. Do you think that's going to make any difference?
Now when approaching infinity, that 3 is useless.
Yeah. Would you agree that this guy here is pretty much like his mother? He just starts a little later. Well, if you put all of them together, won't that also diverge? Stick any number you like in the top, have any multiple of n that you like, and add anything after that that you like. So if you have any series that you can see as a single number on the top over some multiple of n on the bottom, it belongs to the harmonic family. And anything that belongs to the harmonic family, we assume diverges, just like 1 over n, we assume that it diverges. Are you cool with that basic truth, right? So all we need to do now is we're going to go looking, we're going to go hunting for series that are in the harmonic family. So it has to be a fraction with a number on the top, like 5 or 2 or 1. And then on the bottom, it can only have multiples n, like 2n, a half n, 4n, things like that. And it might also have a +2, +5 after that. So it doesn't need to have all those features. It just needs to have like one of them, right? The basic feature. And then we're good to go. And I've just hit the wrong button again. I cannot multitask to save myself. Okay, let's zoom back and I'll start going hunting for guys that are in the harmonic series. Darn it, I think there's only 2 of them, so I'll probably miss it if I'm not careful. All right, nothing. No, that's not there. That's not you. That's not you.
So the one with sine, that's not harmonic, even though it kind of goes up and down.
No. The sine 500 one to the power of n, that one? Is that the one you're talking about?
No, there's one that I think is sine of n or something like that.
That's divergent, but for a different reason. I know there's a harmonic in here. We get past it. Oh, here we go. Let's look at that guy and then try and see why he's a member of the harmonic series.
That's going to be 1 over 9 times n.
Well, you nailed it. Okay, are you happy with that being a 1 over 9n guy? Isn't that harmonic? So it diverges. So if you were trying to prove that to me, you would simply probably write a sentence in English, right? I think there's another harmonic. I could be proved wrong, of course. Oh, here's one. Forget about this piece. This piece doesn't matter. See the 5 over 6n? And you might say, well, why doesn't that matter? Well, let's look at the other bit. Isn't 2 over n harmonic? If you're harmonic, doesn't that mean you add up to infinity? Do you think it really matters what else you add on to it? Won't it still be divergent? Oh, it's an infinity plus another 4 isn't going to make a lot of difference. Or an infinity take away another 4 isn't going to make any difference. So when you're looking at question 28, shouldn't you just focus on the 2 over n guy? And say, I don't really care what the other one is. Do you know what the 5 over 6n is? Anybody recognize him?
Geometric?
Yeah. So it's probably going to add, I'm making a number, it's probably going to add up to 5. but infinity plus 5 doesn't really do anything, right? It's still divergent. I think that's it. I'm pretty sure. Yep, it is. So would you agree the harmonics really just a very minor, yeah, 2 questions. You're not seeing it a lot, but it is there, which means that I have a time to start talking, but only talking about the last one. So let's look at telescoping series. And I'll start by picking one and showing you how it works. Picking a nice easy one to start with. I know they're in here, I just have to find them. If not, I'll make up my own, I guess. Come on. Ah, here we go. Suppose I have a series that looks like this. You will know that you've got a telescoping series because it will have 2 terms, always subtracted. So if you ever see a series where it's ugly guy, take away a very similar looking ugly guy, right? You're looking at a telescoping series. So for instance, E 2 over n, take away E 2 over n plus 1. Right? Ugly guy, take away ugly guy. Would you agree that they're similar looking? So how do telescoping series work? How do we find out what they converge to if they converge? Rather clunky. You would hope it was some really elegant where I would just say if R is bigger than 1, it diverges. No, it goes like this. You plug in n equals 1. And if you plug in 1 here, you get that. And then you add, you plug in n equals 2. And I wish I'd written slower. I'm going to have to rewrite this smaller. That's what I meant to say. Right, there's n equals 1, right? Then you plug n equals 2. You plug n equals 3. And then you go plus, dot, 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 dot. And then you imagine that you kind of randomly stop at n. And then later on, we'll make n go infinite, right? Now, let's see if we can simplify this big, horrible expression. Do you see anything canceling with anything else?
Well, if we could subtract or we could factor out in E.
Oh, I wouldn't do that. No, no, wouldn't do that. Think about this guy gets killed off by that guy.
Can
Telescoping
we
series.
add 1 plus the series onto the end and then subtract?
That might work. I was thinking some much more straightforward. Wouldn't that guy get killed by that guy? Wait a minute. What will happen to this guy when he get killed off by that guy? Can you imagine? Wouldn't this keep on going? This guy gets killed off later by that guy. This guy gets killed off later by that guy. Now, if you can imagine that pattern continuing, right? Won't this guy here, because if you notice, somebody gets killed off, somebody gets killed off, somebody gets killed off. Won't this guy get killed off by a guy that would be there if I roll? Have you noticed that the guys that get killed off are always next to each other? So wouldn't this guy get killed off by the one that went there? Now, what does that mean that we have left? It means that we have this fella take away this fella. Wouldn't that be the only people left alive when you add up all the terms? One at the start and one at the finish. Now, what's going to happen when we make n go infinite? Well, that's still a number. What is that guy going to equal when n goes infinite on you?
E to the 0, which is going to be 1.
So we can now say, not only that it converges, do you see we even get as an extra free gift, we even get to find out what it will converge to. Now let's show you, yeah, I've got enough time. Let's show you one that diverges, right? Because that can happen. Things can diverge. Can I find one quickly? If not, I'll make one up. I'll just make one up. Suppose you got yeah, square root of n plus 1, take away the square root of n, right? Let's suppose we're doing that. Right. If you plug in 1, it becomes the square root of 2, take away the square root of 1, right? That's what you get when you plug 1 in. Right, if you plug n equals 2, you get the square root of 3, take away square root of 2. And then the next time you get the square root of 4, take away the square root of 3, right? And then dot, 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 dot. And you'd finish with that guy, right? Okay, let's see who's killing each other off this time. Does the square root of 2 or the square root of 1 get killed off by something that comes later? Which one of these two will
Square root of
disappear?
2 gets
Okay.
killed off later.
Right. Does the square root of 3 get killed off? Yep. Would you agree that this square root of 4 would get killed off and everybody else would be killed off? Now, one of these two terms is going to make it out alive. Do you notice it was the second term that survived? So which one of these two do you think is going to make it out alive, at least as far as where we've stopped is concerned?
Negative square root of 1.
Correct. And what about from here? Which one of these two is going to make it out alive?
Would it be the square root of n plus 1?
Correct. Have you noticed that if the second one lives, oops, I put the cross, you're correct, I've just put across the row the wrong one, right? That one's going to make it alive. Have you noticed that if this one survives, then that one survives? You notice if it's the first one that makes it, the last one makes it. If the second one makes it, the first one makes it. If you notice, that's kind of the way the pattern works. So we've got this guy, and that one makes it. Oh, wait a minute. What is going to happen when n goes infinite now? What will this expression become when n goes infinite? And infinity means what? It means it diverges. Do you see we can tell when it diverges and converges by using this method? So when you are doing telescoping series, don't you have to write down at least 3 or 4 terms just to get a feel for what the heck's going on, right? And then once you've figured that out, typically you get 2, sometimes you get 4 terms left alive, hopefully 2. And then you just say, okay, what would happen if n became infinity? Although I haven't mentioned it, do you know I'm just doing the partial sum Sn when I write this down? And then I'm saying what happens to Sn when it goes infinite, which is kind of what's happening from here to here. Did we learn some cool stuff today?